Okay, let's start with the distortion. This distortion is the second cause for the transmission impairment, right? Distortion says, I mean, it means that signal change its form or the shape. So if you look at this image, see the send signal will be in this form when it is transmitted over the transmission medium or the channel. You can see the changes in the shape of the signal. See here, it the shape of the signal has been changed at this point, this point, this point, this point, right? So this is called as distortion. Okay, so next reason or the cause for the transmission impairment is noise, right? This noise is can be maybe of several types. Okay, before looking into the types of noise, let's consider this image. Okay, like how noise causes impairment. Okay, see here, when this, see, the signal is transmitted over this transmission medium, or you sorry students, had lost the connection. So let me start it again. Am I audible? Yes?
Yes, ma'am.
Okay, okay. So there is too much network problem at my place. I'm so sorry. Yeah. Okay, here. See, considering this image, when the signal is transmitted over this communication channel, noise has been introduced into the signal. So you can see at the receiver end, the signal has been changed. That means noise will be induced, or noise will be there in the signal which is received at the receiver end. So the quality of the signal may be deteriorated. Okay. So there are several types which causes noise in the signal. Let's start with one by one. The first one is thermal noise, which is a random motion of electrons in a wire which creates extra signal not originally sent from the transmitter. What does it mean? When signal travels over the transmission medium, say the transmission medium here is a wire. Okay, so the when what signal flows through this, there will be a random motion of the electrons in the wire, so which creates extra signal along with the signal one which has been sent over the transmission channel from the sender side. Okay, so this extra signal we call it as noise here. Okay, so and the next type is induced noise. which comes from the sources such as motors and the appliances. So this is another kind of noise. And third type is crosstalk. This is the effect of one wire on the other wire. Okay, we usually face this when we talk over the phone, right? So we may cross connect to other number, not one with one, not with a person whom we wanted to talk, right? So that we call it as crosstalk. This is also one type of noise. And the next type is impulse noise. So it is a spike that comes from the power lines, lightning, and so on. This is another kind of noise that can be what introduced into the signal when it travels over the transmission medium. Okay, these are the four types of noise. So you know that when there is noise induced in the signal, the quality of the signal deteriorates, and the data that we are supposed to receive at the receiver end maybe the may not be a good quality one, right? So in that case, it should be, I mean to say that you have to calculate the signal to noise ratio. See, what is the signal to noise ratio? So that will decide the quality of the signal. Okay, so here comes the topic wherein we are going to calculate signal to noise ratio. The formula goes like this: SNR, in short we call it as SNR, and SNR is equal to average signal power divided by average noise power. Okay, and signal transmitted over the transmission medium, then the average signal power is considered, and average noise power will be considered. Okay, this average signal power divided by average noise power will give you the SNR. Okay, so this SNR says, if one second. If SNR value is high, then it says the signal is less corrupted. Okay, less corrupted by the noise. And if the value of SNR is low, then you can see the signal is more corrupted by the noise. Okay, and this SNR, that is signal to noise ratio, is expressed or described in decibel units, that is SNR dB. Okay, and the formula to find out this SNR dB is 10 log of SNR to the base 10. And do remember here, to find out SNR in dB, first you need to have signal to noise ratio. Okay, so the signal to noise ratio is described in the form of decibel units. Okay, that you have to remember. Fine. So when it comes to attenuation of a signal, there also we expressed attenuated signal in the form of decibels, right? That is represented as dB. Whereas with respect to signal to noise ratio, we present it as SNR dB. Okay, so you have to remember the formula. SNR is equal to average signal power divided by average noise power. Okay, and SNR dB is equal to 10 log of SNR to the base 10. Okay, so that is the formula. Let's see few problems under this topic. Okay, so let's consider the problem here. The power of a signal is 10 milliwatt, and the power of noise is 1 microwatt. Okay, what are the values of SNR and SNR dB? So here they have given power of a signal, that means average power signal, that is 10 milliwatt. Okay, then power of the noise is 1 microwatt, that means it is average noise signal. Okay, so these two values are given, and you have been asked to find out SNR. So what is the formula to find out SNR? SNR is equal to average power signal divided by average noise signal, right? So average signal power divided by average noise power. Okay, so just substitute the value. What is the power of signal? Average signal, this for at this place substitute 10 milliwatt, and at average noise power, you substitute 1 microwatt. Okay, just see here. So this is in microwatt, just converted this value into microwatt. Okay, that comes to 10. So it is a milliwatt, right? So convert that to microwatt and divided by 1 microwatt, which comes to 10,000. Okay, now this you have to express it in SNR dB. What is the formula for that? SNR dB is equal to 10. One second, it's not showing. Okay, now substitute this, since you have the value of SNR, substitute this value at SNR here. So that comes to, one second, it's not reflecting. Yeah, yeah. 1 second, student. Just 2 minutes. See, is my screen visible now? Someone answer me. Is my screen visible?
No, ma'am.
No. I'm so sorry. There's network issue. Yeah. So this is the problem which I was solving, right? Substitute SNR value, that is 10,000, substitute here and then simplify it. You will get 40 decibels here. Okay. Next problem. Consider a signal with 200 milliwatts power passes through 10 devices. See here, the signal strength is given, that is 200 milliwatts power. Okay, and it passes through how many devices? 10 devices. Okay, each with an average noise of 2 microwatts. Do you remember? They have given average noise power, that is 2 microwatts with respect to one device. So you have to find out for 10, what is the average noise power for 10 devices. Okay, so then the question is, what is SNR for this and what is SNR dB? Okay, let's start with SNR. SNR is average signal power divided by average noise power, right? The average signal power they have already given in the question, that is 20 milliwatts. Okay, and for one device they have given the average noise power, that is 2 microwatt, which you have to multiply it for 10 devices. That means 200 milliwatts divided by 10 into 2 microwatts. Okay, so simplify this. SNR comes to 10,000, and then you have to find out SNR dB. Okay, so consider the formula, that is 10 log of SNR to the base 10. Substitute the value and simplify it. You will get the SNR dB. Again, here also it is 40 decibels. Okay, so next topic is data rate limits. See, this is one of the important topic, or when it comes to communication or the network, it is one of the important consideration that you have, that everyone has to follow, because it says how fast we can send data in bits per second over a channel. Okay, data rate limits is what? How fast you can send the data in bits per second over a channel. Okay, so for 1 minute, sorry, for 1 second, how many bits you can send, okay, of your data, how fast you can send, that we call it as data rate limits. Okay, and this data rate depends on three factors, as you can see here. One is bandwidth available. Okay, the second one is the level of signals we use. See, this part we studied in the initial class of this chapter. See, digital signals can be sent over the transmission media following more than two or more levels, right? So that is log m to the base 2. I hope you remember. Okay, that levels I'm talking about here, the levels of the signals we use. Okay, and the last one is the quality of the channel, that means the level of noise. So all these three factors decides data rate of a transmission channel. Okay, so with respect to that, you have noiseless channel. Okay, another one is noisy channel. Okay, so when it is a noiseless channel, you can find the bit rate, okay, using Nyquist formula. Okay, I'll repeat. When there is a noiseless channel, and that means there is no noise induced into the signal when it travels over the channel, then we call that as a noiseless channel. And for this, you can find the bitrate by following Nyquist bitrate formula. Okay, so that is, it defines theoretical maximum bitrate. Okay, Nyquist bitrate formula defines the theoretical maximum bitrate. Okay, for the channel, what is the maximum bitrate? That you can find out using Nyquist bitrate. Okay, the formula goes like this. Nyquist, see this formula, we call it as Nyquist bitrate itself. Okay, Nyquist bitrate is equal to 2 into bandwidth into log L to the base 2. Okay, so this bandwidth, it is the bandwidth of the channel. Okay, log L is the number of levels used to pass the signal over the channel and to the base 2. Okay, this is used to find out the bit rate of the for the noiseless channel. Okay, so that is what it says. Bandwidth is bandwidth of the channel. L is the number of signal level used to represent data, and bitrate is the bits per second. Okay, so let's consider a problem for this topic. In the question they have given, consider a noiseless channel, okay, with a bandwidth of 3000 hertz. So the bandwidth of the channel is given and it is 3000 hertz. You can make out here it is a noiseless channel. So in that case, you have to use Nyquist bitrate. Okay, this hertz 3000 hertz transmitting a signal with two signal levels. They have given L value also, that is two signal level. Okay, the formula you have to remember, 2 into bandwidth into log L to the base 2. Okay, so now we have what bandwidth value and the L value. You just need to substitute the values in the formula and find the maximum bit rate. Okay, let's see that. Nyquist bit rate is given as 2 into bandwidth into log L to the base 2. Substitute the value. Bandwidth is 3000 and L value is 2 because here two signal levels are given. Substitute and simplify. That will give you 6000 bits per second. Bit rate is expressed in the form of bits per second. Okay, this is one question, and let's move on to the next question, where four levels are given. Only this change has been made in the question. Instead of two, they have given four levels. Substitute that value and simplify it. That will give you the bit rate. Okay. Next, consider this. We need to send 265 kilobits per second over a noiseless channel with a bandwidth of 20 kilohertz. Okay, how many signal levels do we need? In the question, they have already given, see this is bits per second, right? They have already given the bit rate, okay, and the bandwidth of the channel. They have asked you to find out signal levels do we that we need for this. Okay, so consider what Nyquist bitrate formula and substitute the value given here and find out signal levels. Let's see the formula. Formula is bitrate is equal to 2 into bandwidth into log L to the base 2, right? What is bitrate? It is 265 kilobits per second. Substitute this value. You substitute this value at the place of bitrate and bandwidth as 20 kilohertz at the place of bandwidth and simplify. So substitute this, then find out L value. L is equal to 2 power of 6.625. Simplify that, that will give you 98.7 levels. Okay, I hope you followed this. See, all the problems are easy, but you have to remember the formulas. Okay, that is all about noiseless channel. Okay, now we'll move on to the noisy channel. See, that means there is a noise in the signal when it travels, when a signal travels over the channel or the transmission medium. That we call it as Shannon capacity. Okay, the previous one, noiseless channel, we call it as Nyquist, whereas noisy channel, we call it as Shannon capacity. We'll see that actually in theoretical, we may have noiseless channel, okay? But in reality, there will be noise in the channel, okay? So that is what it says. So the channel is always noisy, okay? So that we call it as Shannon's capacity, and the theoretical highest data rate for a noisy channel is calculated by following Shannon's capacity formula, that is bandwidth into log of 1 plus SNR to the base 2. Okay, so do remember for noiseless channel, bitrate is calculated using Nyquist bitrate, whereas for the noisy channel, bitrate will be calculated by following Shannon's capacity, that is bandwidth into log of 1 plus SNR to the base 2. Okay, bandwidth is bandwidth of the channel. Okay, SNR is signal to noise ratio. How do you find signal to noise ratio? We already studied the formula. That is signal to noise ratio is equal to average signal power divided by average noise power, right? So that you have to include here to find out the SNR. Okay, this is the formula with respect to noisy channel. Okay, let's see a few problems under this. Let's consider there is an extremely noisy channel in which the value of signal to noise ratio is almost zero. See here, signal to noise ratio, that is SNR. Here SNR is 0. Okay, and they have asked us to consider the noisy channel. That means you have to use Shannon's capacity. Okay, and calculate Shannon capacity. Just for consider the formula and substitute the value here. Okay, bandwidth into log of 1 plus 0 to the base 2. Right, simplify that. This comes to 0. Anything multiplied by 0 is always 0. Right, the capacity is 0 here. Fine. So this is one problem. Let's consider the next problem, where a telephone line normally has a bandwidth of 3000. See here, the telephone line is the transmission channel considered, and bandwidth of the channel is 3000, and signal to noise ratio is 3162, that is 3162. For this, calculate the Shannon's capacity. They have given everything, just substitute in the formula. Bandwidth is 3000 log 2 of 1 plus 3162. Simplify this, whatever the value that you will get, that will be capacity, that is bit rate. Okay, so this is one more problem. The next problem, this is a bit tricky. You have to concentrate here. Assume that SNR dB is given, that is SNR decibel is equal to 36, and the channel bandwidth is 2 megahertz. Calculate Shannon capacity. See, they have not given SNR value, but they have given SNR dB value here, right? So, with this data, they have asked us to find out Shannon capacity. So, first let us consider the formula for the Shannon's capacity. Have they given bandwidth? Yes, they have given, that is 2 megahertz. Okay. Then SNR, have they given SNR value? No, they have not given, but they have given SNR dB value, that is 36. Okay, let's recall the SNR dB formula. What is SNR dB formula? It is 10 log of SNR to the base 10, right? You have the value of SNR dB, substitute there and find out what is SNR. Once you calculate SNR, you substitute this value in the place of SNR here and bandwidth value as 2 megahertz and simplify that. That will give you Shannon's capacity. Okay, I hope this is clear to you. That is SNR is equal to, so I'm just taking this SNR at this left hand side, and this becomes 10 power of SNR dB divided by 10. Simplify this. Okay, it comes to 3981. Okay, now substitute this value in this SNR. That is bandwidth is what? It's given us 2 into megahertz, right? Just I expressed in this form 2 power of 6 into log of 1 plus 3981, that is this value, plus to the base 2. Simplify this, it comes to 24 megabits per second. Okay, so that is about this problem. The next one, see, I hope you all following the problems, because these are all simple problems, but the thing is you have to remember the formulas. Okay, so let's see another problem where they have given a channel with 1 megahertz bandwidth. What is the bandwidth of the channel? It is 1 megahertz. Bandwidth is given. The SNR for this channel is 63. SNR is also given, that is 63. Now they have asked you to find out what are the appropriate bit rate and the signal level. So you have to find out what is the appropriate bit rate for this channel, okay, and signal level. Okay, so see, they are not directly asked you have to use whether Shannon's capacity or Nyquist bitrate, right? So, but in the question you can consider that here you have been asked to find out signal level. So, signal level is one of the component in Nyquist bitrate, right? So let us consider, keeping this mind, first we will find out what is the appropriate bitrate. Okay, so as in the theory I explained, this Shannon capacity is used to find out the upper limit, that is highest data rate, highest bit rate. Okay, so with that point, let us consider Shannon capacity. I'll repeat it again. They have asked in the question to find out what are the appropriate bit rate. Okay, and find out signal level, right? To find out appropriate bit rate, you have to use what you should know what is the upper limit. That means highest data rate for the channel that you can find out with the help of Shannon capacity. So I'll just consider the Shannon capacity formula, that is bandwidth into log of 1 plus SNR to the base 2. I have bandwidth value 1 megahertz and SNR value, that is 63. I'll just substitute here. Okay, so that comes to 6 megabits per second. So this is the highest or the upper limit data rate. Okay, with this data rate, you can consider the appropriate bit rate. Okay, because this is the highest data rate that can be considered for the channel. Okay, but you have to find out appropriate bit rate. So in that, with respect to that, since 6 is the upper limit, I'll take it as 4 as the uh, bit rate for this. Okay, 6 is the upper limit, so something lower I'll be considering, that is 4 megabits per second. Okay, so considering this, you have to find out signal level. So the signal level, so that's why I'll consider Nyquist formula. It goes like this: 2 into bandwidth into log L to the base 2. Substitute the value. Bitrate is 4 Mbps, bandwidth is 1 megahertz, and L value you have to find out. Simplify this, that comes to L is equal to 4. So 4 signal levels are required for this channel. I hope this problem is clear. Is this clear to everyone? This is not a regular kind of problem. So you have to think for a while before solving this. Is this problem clear to everyone? Please respond.
Yes, ma'am.
Okay. Next, another type of question where consider a line has a SNR as 1000 and a bandwidth of 4 kilohertz. What is the maximum data rate supported by this line? So maximum data rate is what? You have to consider Shannon's capacity. Okay, so that will give you maximum data rate for the channel. So consider that formula, substitute, bandwidth is given, SNR is given, substitute the value and simplify it. See, in the question they have not directly mentioned whether it is a noiseless channel or noisy channel, but they have given a hint or a word, maximum data rate. So that means you have to consider Shannon's capacity. Okay, if they have asked you to find out something like this appropriate data rate, then you have to consider Nyquist bit rate. Okay, so for this formula, substitute all the values and simplify. That comes around 40 kilobits per second. Okay, next, another question here. See, we measure the performance of a telephone line 4 kilohertz bandwidth. Okay, the telephone line bandwidth is 4 kilohertz. Okay, when signal is 10 volts, the signal power is what? 10 volts. Do you remember? Signal power is 10 volts and the noise is 5 millivolts. Okay, so if this is given signal power and the noise power, then what it is? It is SNR. How do you calculate SNR? That is signal to noise ratio. Average signal power divided by average noise power, right? So average signal power is 10 volts here. Average noise power is 5 millivolts. Okay. For this, you have to find out what is the maximum data rate supported by this telephone line. Okay. So which formula you can use? One second. So I just listed whatever the data is given. Bandwidth is given, average signal power is given, and average noise power is given. So as I said in the previous problem, maximum data rate is nothing but you have to find out Shannon capacity. Consider that formula wherein data rate is equal to B into log of 1 plus SNR, right? What is SNR? That is this value divided by this. That is what it says. Since they have not given directly SNR value, but they have mentioned these two values, using which find out SNR and substitute value for that, and that comes to what 43,866 bits per second. Okay. So that is all about Shannon's capacity. So this performance, I have to cover the last part, that is performance, to complete this chapter. Okay, so under which you are going to study what are the factors that decides performance of a network. Okay, that is bandwidth, throughput, latency, and then jitter. Okay, these are the topics which I'm supposed to cover under performance. So do you have any doubts till this point?